Example 5. Test the convergence of the series, the sum from n equals 1 to infinity of n to the power n over n factorial. Solution. Since the terms a sub n equals n to the power n over n factorial are positive, we don't need the absolute value signs. The a sub n plus 1 over a sub n equals open n plus 1 close to the power n plus 1 over open n plus 1 close factorial times n factorial over n to the power n equals open n plus 1 close open n plus 1 close to the power n over open n plus 1 close n factorial times n factorial over n to the power n equals open n plus 1 over n close to the power n equals open 1 plus 1 over n close to the power n approaches e as n approaches infinity. See equation 3.6.6. Since e is greater than 1, the given series is divergent by the ratio test. Note, although the ratio test works in example 5, an easier method is to use the test for divergence. Since a sub n equals n to the power n over n factorial equals n times n times n times n and so forth over 1 times 2 times 3 and so forth times n is greater than or equal to n, it follows that a sub n does not approach 0 as n approaches infinity. Therefore, the given series is divergent by the test for divergence. The following test is convenient to apply when nth powers occur. Its proof is similar to the proof of the ratio test and is left as exercise 49. The root test. Number 1. If the limit as n approaches infinity of the nth root of the absolute value of a sub n equals big L less than 1, then the series, the sum of n equals 1 to infinity of a sub n, is absolutely convergent and therefore convergent. Number 2, if the limit as n approaches infinity of the nth root of the absolute value of a sub n equals big L, which is greater than 1, or the limit as n approaches infinity of the nth root of the absolute value of a sub n equals infinity, then the series, the sum from n equals 1 to infinity of a sub n is divergent. Number 3, if the limit as n approaches infinity of the nth root of the absolute value of a sub n equals 1, the root test is inconclusive. If the limit as n approaches infinity of the nth root of the absolute value of a sub n equals 1, then part 3 of the root test says that the test gives no further information. The series, the sum of a sub n, could converge or diverge. If big L equals 1 in the ratio test, don't try the root test because big L will again be 1. And if big L equals 1 in the root test, don't try the ratio test because it will fail too.